It's just eating. And it built a better subway map than we did. In 2010, a team of Japanese scientists placed 36 oat flakes on a wet petri dish. Each flake marked the position of a major city around Tokyo. Then they released a slime mold at the center. 26 hours later, the slime had connected every single flake with a network nearly identical to the actual Tokyo rail system, which took us over 100 years to design. And the slime mold doesn't have a brain. No brain, no neurons, no nervous system. It's not an animal. It's not a plant. It's not even a fungus. It's something else. You're looking at Physarum polycephalum, a single-celled organism that can grow to cover an entire square meter. A cell with thousands of nuclei. One body, no center. It has existed essentially unchanged for around 720 million years. Let that number land. 720 million years. Before dinosaurs, before mammals, before plants figured out how to grow on land, before your oldest ancestor had a spine. This yellow organism was already doing exactly what it does now. And in all that time, it has gotten very, very good at one thing: finding the best way between 2 points. In 2010, Atsushi Tero, a biologist at Hokkaido University, designed a simple test. He took a map of the region around Tokyo, 36 cities, and translated it onto a wet petri dish. Each city became an oat flake, each oat flake a point of food. He placed the slime mold at the location of Tokyo itself and stepped back. There was one more step. Tero knew that Physarum hates light, so he shone bright LEDs onto the parts of the dish that corresponded to mountains, lakes, ocean, geographic barriers, the places a real rail engineer would route around. Then he walked away. And for the next 26 hours, the slime mold did what it has done for 720 million years. It built a network. At first, it did what we'd expect. It explored. Tendrils pushed out in every direction, connecting every flake, forming a dense, inefficient mesh. But then, it started pruning. The tubes that carried more nutrients got thicker. The tubes that carried less were abandoned. The network optimized itself. When Tero compared the slime mold's network to the actual Tokyo rail system, the results were not subtle. He measured 3 things: total network length, fault tolerance, and transport efficiency. Length, comparable. Fault tolerance, comparable. Efficiency, comparable. Comparable to a network that took us over a century to engineer. And here is what is hard to sit with. The slime mold doesn't know Tokyo exists. It doesn't know it's solving a problem. It doesn't know the oats are oats. It's just eating. And by eating, it built a better subway map than we did. It's not magic. It's fluid dynamics. Imagine a river system that can remember. Where water flows often, the channel deepens. Where it doesn't, it silts shut. That's Physarum. Its own body is the river, and every pulse is a decision it doesn't know it's making. No central controller, no signal from above, no plan. Just one local rule, applied billions of times across a single body, until the whole network converges on a near-optimal solution. Computer scientists have a name for this: distributed computation. And until Physarum, they thought we invented it. We didn't. It did. 720 million years ago. Ever since Tero's paper was published in the journal Science, something has been shifting, quietly, in engineering. The people who design our networks have started looking at this yellow organism for answers. Today, Physarum-inspired algorithms are being used to route the internet, to balance wireless sensor networks, and to plan the flow of traffic through cities that do not yet exist. All of it modeled on the behavior of a single cell that has been doing this since before anything on land had a spine. And in 2025, a research group showed something even stranger: that a plasmodium can overwrite its own memory when it encounters new information. A single cell, with a form of working memory, without neurons. We are not teaching the slime mold. The slime mold is teaching us. Here is the part most people miss. Physarum has been running this algorithm, flow, reinforce, decay, for nearly 750 million years. Silicon computers have existed for 70. When we look at Tokyo and see a miracle of modern engineering, nature looks at Tokyo and sees a late copy. Every invention, at its root, is a translation. So, what else has been solving our problems? Quietly, patiently, for longer than we've existed. This is the Error Codex, decoding nature with nature's tools.